Alright, let's go to FRQ number 7. This question says, a railroad freight car, which has a mass of 50,000 kilograms, is allowed to coast along a level track at a speed of 5.3 meters per second. It collides and couples with an 18,000 kilogram second car, initially at rest and with the brakes released. What is the speed of these two cars after coupling? Alright, some things you're going to need to know for this one are that, first, coast means that it's just going along the track, and the main reason why they include in the problem is that we don't have to account for acceleration because we don't know how to deal with that yet. Alright, so it's just a constant velocity. Second, this is a collision problem. We won't need our collision formula because this is just a conservation of momentum problem, but it does deal with collision. And yeah, so I've already drawn out the picture. You have one car that's going at 5.3 meters per second that weighs 50,000 kilograms, or that is 50,000 kilograms. And then you have a second car that's 18,000 kilograms, and then you're going to have a total object after coupling that's going to have a mass of the two cars combined, and will go at a who knows rate. That's what you're trying to figure out. Alright, so let's get started. The formulas you're going to need for this one, there's only one. Since it's a law of conservation of momentum question, you're just going to need to know the M1 V1, which is the first P initial, let's say, is equal to M2 V2, which is, let's say, P final. Alright, so we can expand on this. M1 V1, which is the moving car, is equal to M2, which would be really these two cars combined. Alright, so let's say car 1 plus car 2 times V2, which would be the final velocity that we're trying to figure out. And so now that we have our formula written out, we can just plug in and solve. We have M1, which is 50,000, times V1, which is 5.3, equals C1 plus C2, which is 68,000, times V2. Alright, and so you just plug these numbers into your calculator. 50,000 times 5.3 divided by 68,000. And once you do that, you will get that the final answer is 3.40 meters per second. Right? And so this answer, and for step 5, this answer makes sense because when these two railroad cars collide into each other, obviously they're going to slow down. This one is going to slow down because it's impacting something. It's transferring momentum to another object. And so that's why this is going to be slower than the initial speed. Yep, that's how you do this problem.